with molar masses. It's always something that you need to use. Oh, this is a very straightforward question, but molar mass is always something that you need because that's really the only way you can get the grams or get from grams to moles. And a lot of conversion happens surrounding molar mass that it becomes a very crucial part of chemistry. Okay? So now in the question 7, calculate Ka from pKa. Okay? So to do that, actually, there's actually an equation we use. Ka and pKa work the same way as the concentration of H3O and pH. Okay, so if we remember correctly, pH is equal to negative log of H3O plus. Okay, so the only way to be able to convert this back is when you have a log without a base, it's just 10. So that's log 10 of H3O. Okay, and now to be able to convert it out, you want to be able to now get the, in a sense, you want to isolate for the H3O part. So the concentration of H3O, actually, what you have to do is you have to do the to the power of 10. Okay, so it would be 10 to the power of pH is equal to 10 to the power of negative log. Let me just make sure I'm doing this right. Negative log. Nope. Sorry. Almost forgot something before I did that, actually. I want to make sure that you move as many things to the other side first. So it's going to be negative pH is equal to log. There's actually an easy way to do this. Sorry. When you have it written like this, you can do 10. Actually, no, that is the first step. You want to move the negative over. So that's minus pH is equal to log 10 H3O. Okay? And there's going to be 10 to the power of negative pH is equal to concentration of H3O. So that's right here. This is how you go from one equation to the other. But instead of now having the pH and H3O, you want to replace that with pKa and Ka. So actually, if you rewrote it, the actual formula would actually be 10 to the negative Ka. Whoops, sorry, wrong one. pKa is equal to Ka. And yeah, that's all you have to do. Because remember, just think of it as you're solving for a pH, and then you just go back from there. Okay? So exactly, this is correct. And exactly, to understand why we relate pKa to pH is that pKa kind of signifies the, I guess, sort of the acidity of the weak or strong acid. It kind of tells you what pH is probably gonna rest at. That's kind of what pKa implies, and especially becomes very relevant when you're trying to solve for buffer solutions. pKa plays a role there because the pH will be a value that kind of encompasses the pKa. Okay, so now question 8.